Hi, so on the message boards, we get a lot of posts about data. How do I visualize data? How do I plot it? Regressions, what kind of regressions do you have? Can I input my own? So the answer to all those questions is yes. There's a lot you can do with data in space-time. And so let's start by defining a list. So for my X list, I mentioned one of the previous videos that I never use X as the variable because X kind of has a special place in space-time to auto-detect sort of the independent variable when plotting. So whenever I use a list, I usually double up the letter. So for my X list, I'm just going to do a 1, 2, 3, 4, 5, 6, let's go 7. And then to get a new line, I'll do a Shift Enter. And then for my Y values, I want to start with data that kind of goes up and comes back down again. So we'll do say 1.3, 3.4, let's go up to 5, and then we'll come back down slowly. So 4.3, 3.4, and 2, 4, 5. I need 2 more. 2 and a 2. Okay, so if we hit enter, it's only going to display the last line, which is the Y list. And if we hit it, evaluate it again, we get the decimals. So again, if you keep evaluating it, it toggles back and forth between fractions and decimals. So if we want to do a plot of this data, just the data, we can do a list plot and just hit enter, and we get this image right here. And if we want to connect the dots, we can do that, or we can put dots and connect them, or we sort of just toggle through here. You can also change the color too, but I won't. Okay, so we have our data here, and so a couple of things we'd like to do. One is we'd like to find a regression. So the easiest way to do this is to just, in space-time, put in list notation, a list of lists, X and Y, and then this entry button right here, you're going to want to go to Stat, and then there's Regression. And so what this is going to do is it's going to plot the data, just like it did above, and then in addition, there's going to be this bar here that says Select Regression. And so we could click, say, Linear, and it'll plot a linear least squares line, the best fit, which this R value is pretty low, so that tells us that it doesn't do that good of a job. I think a quadratic should do a lot better. Yeah, so the quadratic looks a bit nicer. And then we can do cubic. And I'll just leave this screen up for a little bit. So there's a exponential, there's logarithmic, logistic. So these are pretty standard regressions that you can do. And then there's also sinusoidal. And this last one here is the custom regression. So this is where you can input your own expression. So if we click this, then we get this bar coming up with y equals. And so let's go back just to kind of show with quadratic, there was a y equals, and then it had a times x squared plus b times x plus c. And so this is the form of the equation, and your a, b, and c were the parameters. And so when we do custom regression, this is why I like to leave x as x and not assign it a numerical value or a list. It's because I'm going to now, space-time is going to auto-detect x as the independent variable. And so let's say I want to do a times x times log of x, and we'll add a b times x as well. Okay, so now what it's going to do is it's going to fit a line according to this expression, and then it's going to find the best fit line for values of a and b. So if we hit enter, it plots the line that goes through it and then gives you the values of the parameters a and b and this, I guess, goodness of fit parameter r, which is the sum of the squares of the residuals, or r squared. It's basically a measure of how good of a fit this line is to the data. So that's how you do this in sort of the graphical interface. Another thing you can do is use this function there are three different functions. There's regression function, regression parameters, regression plot. And so if you're just interested in it returning this expression with the numbers filled in, then what you can do is you can write regression function, give it the x list, the y list. The x variable is going to be x. The y function is going to be a times x times log of x plus b times x. And then p list is the list of parameters. So I guess p is mnemonic for parameters. So we have an a and a b. And then p-val is sort of this initial guess. So if you saw the Newton method video, what I mentioned briefly that a lot of these numerical algorithms, they need some kind of initial guess to get going, and then it'll converge to a solution. And so when in doubt, just use the vector of all ones. So we'll use 1, 1, and I won't bother with n. So I hit enter, and it fills it in just like I would expect. So you've got this 2.616, 2.616 for the b value, and then you're going to subtract, because our a is negative, this x log x term. Okay, so if you wanted just the function, and then you wanted to work with the regression function, that's what you could do. If you wanted the parameters, so if you're interested primarily in the parameters, let's copy and paste. So I did an apple C. What's nice is I can just put the cursor on the line. I can highlight if I want a subtext, but if I just want the entire line, I just put the cursor there and do a control C. And then I can do a control V here, and now I can modify this. And so I want to do regression parameters, and it returns a matrix of values which has the thing. So if I wanted to say define a variable param, I do this, and I can do param of 1, gives me that row, param of 2, gives me that row, and so then I can set, not B is bad, but let's see, call it parameters equals this, and then I have parameters 1, 2, 3, and then I can work with them as I want. So you can get that. The final thing you can do is, of course, plot it. So again, plotting it, you can use the GUI to that, or if you're just interested in doing everything using the keyboard, which is what I typically prefer to use the keyboard if I have the option. And so if I do regression plot, all I got to do is hit enter, and it plots the regression function there. So that's basically what you can do. There's also a really nice function called, I believe it's polyfit. Yeah, polyfit. There it is. And so what it'll do is, okay, if I do polyfit on, okay, cut to bad editing. All right, so we were talking about polyfit before, and so what I want to do is polyfit takes the form of, you have to input a list of points, and so that plist stands for a list of what's going to be lists. So you can input them by hand, like this, and then 4, 7, and then it outputs a. In this case, they all fit on a line, but if I guess if I change this ever so slightly, yeah, because there are 3 points, the most general exact fit you can get is a second degree polynomial. So in this case, when they all lie in a straight line, then you get just a linear fit. But in general, if you've got n points, your polynomial will need to be of degree n-1. So there is a little trick. The reason I had to edit was because there's a slightly different syntax for polyfit than it is for these regression functions. So polyfit takes a list of xy points. And so what we've done with our xx and our yy is we've just grouped together all of our x values and all of our y values. But this is a good opportunity to kind of introduce just very easy, quick ways to manipulate this data into the form that we want. And so if we do x, x, y, y as a list of lists, we're going to get a matrix. And so basically a list of lists, all of the same size, is interpreted as a matrix. And so this, if we look at this, this set here, and if I put it down here, what I see is that SpaceTime is going to interpret this as a sort of an n by 2 matrix. And up here we have a 2 by n, or 2 by 7. So the easiest way to get around this is to say, okay, well, what if I did xx comma yy, and I wanted to transpose it? So if you want to do the transpose of a matrix, you just do the transpose function. You get that. Another shortcut you could do is this prime. Now, prime when applied to a matrix gives you the transpose. So if we evaluate it again, we get the decimal values. And so what we're going to do is we're going to input into polyfit this sort of transformed list. And when we do this, boom, we get, so it was a list with 7 points, and we ended up with a 6th degree polynomial. And these are the coefficients. And of course, if I evaluate it again, I get everything in decimal form. And I'm showing a lot of digits, so I'm going to go to my options. And this precision thing here, I'm going to move that back to, let's say, 5. If I hit enter again. Okay, so it gives me the fractional form first, and then I've got, if you click and drag, if it goes off to the side like it did before, all you got to do is click and drag and move it one direction or the other. Also, clicking copies this to the clipboard. So if all I got to do now is do a Control V, and I've got the expression.